So I've been hinting at probability, and so I want to talk about and define probability. And probability comes from many different ways. And so what we talk about is we'll talk about a sample space. And we'll have some experiment that has a sample space. And so, for example, the sample space of flipping a coin is heads or tails. And if I count the number of outcomes, those are my possibilities. And how many distinct outcomes there are define the sample space. So if I want to talk about every possibility in an experiment or some unknown, I look at all the possible things that can happen. So flipping a coin, I can have a heads or a tails. It's flipping a coin once. And so what we do is we will talk about events being some outcome, some result from the sample space. And we can have simple events, which are just one outcome, or we can have non-simple events or complex events that have multiple distinctions on their outcome. So if I look at an event of flipping a coin, I can say the probability of an event is the number of outcomes in the event divided by the total number of possible outcomes. And so we'll say number in event over the number in the sample space. So for flipping a coin, the event that I get a tails, the probability of that is, well, there's one event there, and there's two in the sample space, or it's a 50-50, or 1/2. If I look at something a little more complex, like rolling a die, right, a die has a sample space of, I could roll a 1, I could roll a 2, I could roll a 3, I could roll a 4, I could roll a 5, I could roll a 6. And so there's 6 possibilities in the sample space. Well, I could have an event where I roll let's say I roll less than 2 or less. So I roll a 1 or a 2. Then my probability is, well, I have 2 things in my event, and I have a sample space of 6, or 1/3. And so the probability is 1/3 on this. And these in general we call theoretical probabilities. We talk about the things where we can figure out the sample space and we can figure out the events easily, and we make these theoretical probabilities out of them. Let's look at a deck of cards. Deck of cards has 2 colors in 4 suits. And so we have hearts and diamonds, which are the reds. And then we have, I'm going to highlight these in white because surrounding the black background, we have spades, which are black, and clubs. Oops, kind of a lopsided club there. And so those are the 4 suits in the 2 colors. And then within those suits we have aces, kings, queens, jacks, 10, 9, 8, 7, 6, 5, 4, 3, and 2, or a total of 52 cards. And so we can do some different probabilities out of here. So we have a sample space. The number in the sample space is 52. There are 52 cards. And so I can talk about the probability of pulling a red card. And since there are 2 times the 13 here, that's 26 out of 52, or 1 in 2, or a 50% chance of drawing a red card, which we could kind of see from the number of red versus black cards. There's a 50-50 just from there. We could talk about the probability of drawing a red ace. And so there's 2 red aces out of the 52, or 1 in 26 chance. Which is 0.384 615 384. I'm missing the 0 on that, aren't I? Yep. It's 0.0384, or roughly 3.8%. Right, if we convert this to a percentage. And so these simple probabilities can come from all the possibilities that we can see. And so probabilities determine the chance that something could happen if it's completely random. And this is theoretical. I know how many cards are in there, and I can count what's coming out. Another way of talking about probability is from observation, or we call this empirical probability. I take a survey, and so my probability of an event from an empirical is the observed number the event happens divided by the total number of observations. And so surveys are a good example of that. Let's see if I have a good survey example here. If I survey 254 people, I survey 254 people. I'll make a little table of my results here. And so male and female. And how many were married? Never married. Divorced. Widowed. And so there were 123 men and 131 women, which led to my 254. 3 of the men were widowed. 11 of the women were widowed. 14 total for that. 11 were divorced. 15 were divorced. That's 26 total. And so this is the results of a survey, where we take two questions: are you male or female? Or are you married, never married, divorced, or widowed? And we categorize the answers. And let's look at what this tells us if we turn this into a probability. If this survey is indicative of a larger population, we can say that the probabilities around this survey will be similar to the probabilities from that appear in here. So I could say that the probability that someone was never married, well, that was 81 total out of my 254. Which is approximately 31.89%. And so notice I took the total of both male and female. I could say what was the probability that they were female and never married. Now, if I am just looking at female and never married, well, that's 38 out of the 131 women. Or approximately 0.2900 or 29.00%. 0.01, this rounds up. Sorry about that. And if I was only looking at the female probabilities. In fact, we can use this to kind of talk about how we can combine probabilities and how we can use probabilities. What we're going to do here is we're going to combine the idea of probability and permutations and combinations so that we can look at the ways that probabilities come about. So what we want to look at is we want to look at probability of an event being the outcomes we're looking for, outcomes of the event, over all possible outcomes. And so let's look at a probability for a Powerball. So Powerball is played across the U.S. And so we choose five numbers from 1 to 69, and one Powerball from 1 to 26. And these are from two separate things, so you get all of these and plus the other. And so to win the jackpot, we're going to have a Combinatorics Formula. And so what we're going to look at is we're going to start with the total number of possibilities. And so for the first part here, well, we have 69 balls will be chosen, or 69 balls can be chosen from, but only 5 of them work out. So we have 69, choose 5. Or, and again, I'm not going to jump back and forth to the calculator, but 69C5 gives, there are 11,238,513 possibilities for that. And for the other one, there's 26. So the total would be the fundamental counting principle, or 69 choose 5 times 26, or the 11,238,513 times 26, or 292,201,338 ways of winning. And so your probability of winning on one ticket is 1 out of 292,201, 338, because you have one probability. Now let's say that you bought 5,000 different tickets. And so your probability of winning with those 5,000 would be 5,000 out of 292,201,338, which is approximately 1.71 times 10 to the negative 5th, or 0.1, how many zeros do I have? 4 zeros, or 0.0017% chance of winning. So $5,000 gives you that chance of winning. I don't know, this the first time the Powerball got over, because it's $2 a ticket, 500 million. There was a company that went and bought every unique combination, and got a consortium of people to do it. So everyone chipped in some money, and they would buy every combination, and then you would win shares based off of how much money you went in. But what they didn't count on was more than one person winning. And so they won, but they had to split the jackpot, and so they lost money in the end. In fact, in general, most gambling games are set up so that the probability of winning is small enough that in the long term, the house always wins. And so this is how a combination can go into figuring out probability. And then the Powerball is an example. Let's look at if you have a club of 5 men and 7 women, and you're going to select 3 members at random for a conference. Then what we want to find is the probability that we get 3 men. And so what we have to do is we have to figure out the probability of how many total ways we have of selecting them. So let's turn this into our fraction here. So that's going to be, well, there's 12 people, and we're going to choose 3 men out of it. Now, we want to figure out how many ways that we can get 5 men. Well, we're going to choose 3 out of the 5. 5, choose 3. And so that's going to be 220. If we put this into the calculator, 10, or 1 in 22. And so the probability of choosing 3 men is 1 in 22. And so notice why we started developing this counting. This counting ties back into our numerators and denominators for our probability functions. Alright, what we're going to look at after this is how we can then blend probabilities using ands or ors.